Okay, so this video is meant to be a short explanation of how you can use the unit circle as a reference for evaluating any of the 6 trig functions. So sine, cosine, tangent, and the reciprocal trig functions, cosecant, secant, and cotangent. So on the unit circle, which is just a circle that's centered at the origin and has a radius of 1, for any point that lies on the circle, the x-coordinate can be considered cosine of the angle that corresponds to that point. So the angle whose terminating side of the angle passes through that point on the unit circle. So like if that's the angle theta, the x-coordinate would be cosine of theta, and the y-coordinate would be sine of theta. Okay, so if we wanted to evaluate like cosine of 30 degrees, we would go to 30 degrees on the unit circle, and we would see, okay, well, the x-coordinate at 30 degrees is root 3 over 2. So cosine of 30 degrees would be root 3 over 2. Or same thing with radians, right? Sine of pi over 6 would be the y-coordinate at the angle pi over 6. So you go to the angle pi over 6 and go, okay, well, sine of pi over 6 would be the y-coordinate, which is 1/2. And that's true for any angle that lies on the unit circle. So if you wanted to determine sine of 210 degrees, you would go to the 210 degrees and then look at the y-coordinate there. So sine of 210 degrees would be equal to negative 1/2. And it works for radians as well. So like cosine of pi, you'd go to the angle pi. Cosine is the y-coordinate. So cosine of pi would be equal to negative 1. So you should be able to picture the unit circle in your head, picture the angle, and then the point that corresponds to that angle in order to determine the cosine or the sine. Now, tangent is the ratio of sine over cosine. So in order to evaluate tangent, you're thinking about the point that corresponds to the angle, and it would be the ratio of y over x, the y-coordinate over the x-coordinate. So for example, if you wanted to know what tangent of pi over 6 was, you can write this out. You know, okay, sine over cosine or y over x, so it would be 1/2 divided by root 3 over 2, which ends up being 1 over root 3. If you multiply by 2 over 2, that simplifies to be 1 over root 3, which when you rationalize the denominator is root 3 over 3. You should memorize, I've asked you guys to memorize the values of tangent or be able to quickly determine the values of tangent when thinking about the unit circle. And then the reciprocal trig functions, like the reciprocal of cosine, here, I'll write this down here. The reciprocal of cosine is secant, right? So cosine of theta would be 1 over secant, or maybe I should actually define it as, let's say secant of theta is 1 over cosine. So you can determine what cosine of an angle would be, and then the reciprocal would be the value of secant. And then cosecant of theta is the reciprocal of sine. So you could determine what sine of the angle is, and then the reciprocal. And then cotangent of theta is the reciprocal of tangent. So you can just think, you can figure out what tangent is and then flip it, or you can think cosine over sine. So for example, if I wanted to determine the secant of 11 pi over 6, I would go, okay, secant is the reciprocal of cosine. I think about where 11 pi over 6 is. So cosine of 11 pi over 6 would be root 3 over 2. The reciprocal would be 2 over root 3, which whenever you rationalize would be 2 root 3 over 3. Or if I wanted to determine the cosecant of, how about the cosecant of 5 pi over 4? Okay, so cosecant is the reciprocal of sine. I'd go to the angle of 5 pi over 4. Sine of 5 pi over 4 would be negative root 2 over 2. The reciprocal of that would be negative 2 over root 2, which is actually, if you rationalize the denominator, it's just negative root 2. So cosecant of 5 pi over 4 would be negative root 2. Okay, or for cotangent, like if you wanted to determine the cotangent of 5 pi over 3, you could say, okay, well, cotangent would be cosine over sine. So cotangent of 5 pi over 3 would be cosine over sine, so 1/2 over negative root 3 over 2, which would end up being negative root 3 over 3 when you rationalize the denominator. Okay, so that's how we can evaluate any of the 6 trig functions for angles that lie on the unit circle, which then we can add on angles by if an angle is coterminal to an angle that lies on the unit circle, meaning it terminates in the same position, then we can evaluate any of the 6 trig functions for that angle.